In this video, we shall see about how to evaluate a triple integral with one example. I'll consider the evaluation of triple integral of 1 by 1 plus xy x plus y plus z whole cube into dz into dy into dx. I will be evaluating in the order dz dy dx with limits 0 to 1. This limit is for x and the second integral limit is for y. You observe here it's a function of x. Upper one, lower one can be constant. They can be function of x, and innermost are function of both x and y. Lower limit is again here constant. We'll see how to evaluate this integral. Now this is equal to, here z is the innermost variable, so I will have to integrate this function with respect to z first, keeping the remaining variables, that is y and x, as constant. So first two integral will remain same, that is 0 to 1 and 0 to 1 minus x, and upper limit, inner one I'm integrating. This is something of the form 1 by x plus c whole cube. This function, if I integrate, I'll get 1 by minus 2 into x plus c whole square. Instead of x plus c, here c is nothing but this 1 plus x plus y. This whole term 1 plus x plus y will act as constant term, that is c, and z is the variable here. It becomes 1 plus x plus y plus z whole square into, I have evaluated already with respect to z, so I should not write dz here, dy dx, but this integral I have evaluated only, limit I have not substituted. Limits are 0 to 1 minus x minus y. Now this is equal to, here minus 1 by 2 is constant. I'll keep that outside the integral. Limits, first two integral I'll write as it is, 0 to 1, 0 to 1 minus x. Now for the remaining thing, I'll substitute the limit 1 by, if I substitute, I will be substituting limit for z here. Z will be replaced as 1 minus x minus y. Then x and y get cancelled. We'll get 2 only. We'll remain with 1 by 2. When I substitute z as 0, lower limit, when I substituting lower limit, this will be minus sign. So minus 1 by z as 0, I'll remain with 1 plus x plus y whole square. Here also when I substitute as 0, x, y get cancelled, 1 plus this 1 will remain, 2 whole square is there, so this is 2 square into dy dx. So I have evaluated with respect to z now. Next, in the next remaining variables are y and x. In that, in the order I have, first one is y. Now I have to integrate with respect to y. Again 1 by 2 is constant here. Integration 0 to 1. I'll be integrating this second integral. So I'll keep this 1 by 4 is constant. So 1 by 4 remains as it is. Integration with respect to y, it will be 1y minus 1 by, again similar form. This is x plus c whole square form. Now this will become minus 1 plus x plus y into dx. Again I have to substitute the limits as 0 to 1 minus x. When I substitute the limits here, again 1 by minus 1 by 2 is constant. Integral 0 to 1, 1 by 4. When I substitute limit for y as 1 minus x, that will be 1 minus x by 4 minus lower limit will be 0. And here minus into minus, that will be plus. When I substitute the upper limit, x y. I'll be replacing y as 1 minus x. So x minus x get cancelled. We'll get 1 plus 1, that will be 2. So 1 by 2 minus, this becomes plus. Again this minus comes when I'm substituting lower limit. So when I substitute y as 0, it becomes 1 by 1 plus x. I have to further integrate with respect to x. So dx. Now let us continue further integration. Now it is the usual integration we have seen. Only one time I have to integrate. That's the common way of integration. So I'll quickly complete that. Minus 1 by 2. Integration of 1 by 4 is constant. 1 minus x will be 1 minus x square by 2 plus 1 by 2 integration is 1x by 2 minus, this is 1 by 1 plus x, integration will be log of 1 plus x, limits from 0 to 1. So if I substitute the limit minus 1 by 2 into, when I'll first substitute the upper limit for all the terms, it becomes 1 minus half, that will be half, into 1 by 4, that will be 1 by 8 plus 1 by 2 minus log 2. When I substitute 0, this will be, this term is 0. I think, sorry, I have missed here. Integration of 1 will be x. Okay, even then fine. Upper limits will be remain same here. When I substitute 0, this term will be 0. This is 0. Log 1 will get, that is also 0. Now this is equal to, if you simplify, minus 1 by 2 into 5 by 8 minus log 2. This is the final evaluated answer for the triple integral we have considered. Now you observe here, even though there were functions of x, y, z, when I evaluate, finally whatever I will get will be constant. There will not be terms of x or y or z anywhere.